Okay, let's solve this NPR's Sunday puzzle dated October 31st, 2010. So, what is the problem they gave us? The problem is this: name a creature in 6 letters. So, the creature has a 6 letter name. So, what could it be? Who knows, right? Let's call it A, B, C, D, E, F is the name. Okay. Move first 3 letters to the end. And okay, so we got to move these guys to the end. So what does it become? It becomes D, E, F, A, B, C. Then what do we do? Then read the result backward. So I got to spell this backward. It's intellectual challenge of the day. Okay, I think I made it. So what they're saying is, and then they say this names another creature. So this was a creature's name, and so is this. Okay, of course, not in this case, but we are looking for a word that would do the job. Okay, how do we do this? Can Mathematica do it? Is the question. So let's start doing it. So what I will do is that I don't have a way of getting all the creatures' names. I don't. So what I will do is I will get all the English English words that I can do. So let's do it. And here we go. Here we go. This is a built-in command of Mathematica. You just get Mathematica and run this, you will get it. And there are 149,000, then some words, plus all these words you see in the English language. Okay. Then what do? We want only 6 letter words, right? We don't want all this. So what I'm going to do is that I will take every one of them. That means I will take each one of them. That's what the pound means. And I will check if the string length is 6 out of all words. What are all words? It's this. That's what I just assigned here. So all words means all these words, 149,000 then some. So of those, I will pick the ones that have the length of 6 and then call it 6 letter. Okay, let's do that. Aren't you curious how many I would get? If I do that, I get 8,900 of them, plus these words you see here. Okay, so we reduce the size vastly. How much did we reduce? Quite a lot. About 1 out of 20 is 6 letter words. Okay, and then what do? We have to do the operation they told us to do, right? So I will take the last 3 and put it in front, and I will take the first 3 and put it in the back. Then I will flip it over, and I will do that to every word in 6 letter. What was 6 letter? That's the variable I gave, right? 6 letter. So I will do that to every operation, and I will assign that to a variable called reversed. So you will see all these things you see, these words you see here, being operated the way I just explained. So there we go. So if you compare, let's see a few of them. For example, aken became kane. And that's exactly what they told us to do. If you move the 3 letter to the front and move this first 3 to the back and then spell it backwards, and this is what you get. Okay, I just did it to 8,900 of them. Sure beats doing it by hand, right? That's why we use computers. Okay, so we got that. And then what do? Well, here, we're supposed to find a name of creature in here. Out of this 8,000 some, almost 9,000 words, there was a name of creature. I'm sure there were many in here that after doing the operation, it became another creature's name. As I said, I don't have a list of creatures' names. So what do? So I will say, well, the creature's name was a valid English word in here, and after flipping over, it must have become another valid English name. So, English word. So therefore, whatever they came out here, I will check if this word is in here, because these are valid 6-letter English words. So if after the transformation, the new word, all these are nonsense you see here, but if the result belongs to this list here, then it is valid. So I am not checking 2 creatures' names. I'm checking 2 English valid words. So that's how I'm approaching this here. Okay. So what do? This is the operation I'm going to run. I will check if the reversed, I'm checking every element of the reversed if it belongs to 6-letter. This is the 6-letter here. If it belongs there. The member Q function checks if it's a member. And I will do that to every one of them and just select the ones that actually belonged on the other. So when I run that, aren't you curious how many becomes valid words? Takes a while, even for Mathematica, because I'm checking almost 9,000 of them. Okay, here we go. These are the words that even after you do the operation of moving and reversing, still becomes valid English word. Well, they say it's valid English words, but there are many that I do not recognize. For example, Totara. I don't know what it is. Okay, now, but I don't know what became what. So I'm going to make it show me by doing this operation here. So this is the original word, and it will show me what it became so that I can see if both of them, what it was and what it became, are both names of creatures. But you have a feeling that you know which one it is, right? Because I see raptor and I see parrot. So if these two are matched here, then these would be the answers, right? But let's see if it is the case. So I will have them match for me. So when I do this here, I see all these matches going here, and there are interesting patterns here. Some of them became itself after the transformation, right? You can see even the patterns of how that could happen, but those became itself. But as I said before, the true answers are here. Raptor becomes parrot, and parrot becomes raptor. So this was the answer that they were looking for.